The morning of June 12, 1943, a lone Lockheed P-38 Lightning descended through scattered clouds over the Mediterranean island of Sardinia, its twin Allison engines trailing faint wisps of smoke. The pilot, disoriented and low on fuel after what should have been a routine mission between Gibraltar and Malta, made a choice that would alter the course of his war. He lined up his approach toward the airfield at Capoterra, near Cagliari, and touched down on enemy soil. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow, I've saved something extra special for you. Within minutes, Italian ground crews surrounded the bizarre twin-boomed aircraft, their weapons raised, expecting resistance. Instead, they found an American pilot emerging with his hands up, his face bearing the exhausted resignation of a man who knew his navigation error had just cost him his freedom. But for the Regia Aeronautica, Italy's Royal Air Force, this forced landing represented something far more valuable than a single prisoner. It represented an opportunity to understand the aircraft that had been terrorizing Axis forces across the Mediterranean for months. The Lightning sat largely intact on Italian concrete, its distinctive twin-boom design gleaming in the Mediterranean sun. This was not twisted wreckage requiring months of reconstruction. This was a nearly pristine example of American aviation engineering, complete with functioning engines, intact armament, and all the systems that made the P-38 one of the most feared fighters in the Allied arsenal. The question that had haunted Italian and German pilots since late 1942 was about to be answered through direct experience rather than fragmented combat reports. How did the Americans build a twin-engine fighter that could outrun, outclimb, and outgun anything the Axis could field? The aircraft represented more than tactical intelligence. It symbolized a fundamental challenge to everything Axis aviation doctrine held sacred. European fighter design had evolved along a clear path, emphasizing lightweight construction, powerful single engines, and exceptional maneuverability in close-quarters dogfighting. The Messerschmitt Bf 109 epitomized this philosophy, a nimble predator built to win through agility and pilot skill. The Lightning contradicted every assumption. It was massive, heavy, powered by two engines where convention demanded one, and seemingly designed for a completely different kind of aerial warfare. Italian intelligence officers at Cagliari immediately recognized the significance of their prize. They ordered the aircraft secured, posted guards, and dispatched urgent cables to Rome. Within hours, the Regia Aeronautica's most experienced test pilot received orders to travel to Sardinia. Lieutenant Colonel Angelo Tondi had built his reputation evaluating captured Allied aircraft and pushing Italian designs to their limits. Now he would have the opportunity to fly what many considered the most advanced American fighter in operational service. The Lightning was coming to Guidonia. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. By mid-1943, the air war over the Mediterranean had evolved into a brutal contest of attrition and adaptation. Allied air superiority was not yet assured, but the balance was shifting inexorably against the Axis. Italian pilots, once confident in their Machi fighters and the superiority of their training, now faced an enemy with seemingly unlimited resources and increasingly sophisticated aircraft. The P-38 Lightning had become the symbol of this material imbalance, appearing over North Africa, Sicily, and mainland Italy, with increasing frequency and devastating effect. Italian fighter pilots had been reporting troubling encounters with the Lightning since its introduction to the theatre in November 1942. The aircraft's performance characteristics seemed almost impossible. Pilots described watching Lightnings accelerate away from pursuits as if Italian fighters were standing still. They reported the American aircraft climbing to altitudes where Italian engines gasped for air and lost power. Most frustrating of all, when Italian pilots did manage favorable attacking positions, the Lightning's concentrated nose-mounted armament, 4 50-caliber machine guns and one 20mm cannon firing in perfect parallel, delivered devastating firepower at ranges where wing-mounted guns were still converging. The psychological impact of facing an apparently superior opponent began eroding Italian pilot morale well before the capture at Capoterra. Combat reports from North Africa told a consistent story of frustration and tactical impotence. Italian pilots flying Mach-E C-202 Folgores, themselves excellent aircraft by European standards, found they could not catch Lightnings in level flight, could not climb with them to altitude, and could not force combat when American pilots chose to disengage. The few successful engagements against P-38 seconds typically resulted from ambush or numerical superiority, not from any inherent advantage in Italian aircraft or tactics. German pilots operating alongside Italian units reported similar experiences. Luftwaffe intelligence had compiled extensive files on the Lightning, drawing from combat encounters, crashed aircraft examination, and the interrogation of captured American pilots. The reports painted a picture of an aircraft that violated established fighter design principles, yet somehow achieved remarkable combat effectiveness. German analysts struggled to reconcile the Lightning's substantial weight, its twin-engine complexity, and its unconventional layout with its demonstrated performance advantages. The prevailing Axis assessment held that American aircraft design emphasized brute force over elegance, quantity over quality, and simple ruggedness over sophisticated engineering. This comfortable assumption helped explain why American industry could produce thousands of aircraft, while Axis factories struggled to replace losses. But the Lightning challenged this narrative. Here was an aircraft that appeared both sophisticated and effective, combining advanced supercharger technology, tricycle landing gear, concentrated firepower, and exceptional range into a coherent design that worked. If American engineers could create something this capable, what did that reveal about the true state of American aviation technology? The Lightning's appearance had forced tactical adjustments across the Mediterranean theater. Axis fighters learned to avoid prolonged engagements, to attack only when holding overwhelming positional advantage, and to disengage immediately if Lightnings appeared at altitude with speed advantage. These defensive tactics preserved pilot lives, but conceded air superiority to the Americans. Italian and German bomber formations required increasingly heavy fighter escorts, diverting resources from offensive operations. The strategic initiative was slipping away, and the Lightning represented one visible manifestation of that larger strategic reality. Guidonia Airfield, located approximately 15 miles northeast of Rome, served as the Regia Aeronautica's primary testing and evaluation facility. Here, Italian engineers developed new aircraft designs, tested modifications to operational types, and systematically examined captured enemy equipment. By 1943, Guidonia had become a strange museum of Allied aviation, where British Spitfires sat alongside American bombers and Soviet fighters, each bearing Italian markings and providing insights into enemy capabilities. The facility maintained a small cadre of exceptional test pilots, men who combined technical knowledge with flying skill and the analytical mindset necessary to extract meaningful intelligence from evaluation flights. These pilots understood they were not merely flying interesting foreign aircraft, they were gathering tactical intelligence that could influence combat operations across the entire theater. Every flight generated reports that would be analyzed, distributed, and incorporated into training programs for frontline squadrons. Lieutenant Colonel Angelo Tondi stood at the pinnacle of this specialized community. His career had encompassed both combat operations and test flying, giving him the perspective to evaluate aircraft not merely as engineering projects, but as weapons systems that would determine whether pilots lived or died in combat. Tondi had flown virtually every Italian fighter type, understood their strengths and limitations intimately, and had accumulated hundreds of hours evaluating captured Allied aircraft. When the Lightning arrived at Guidonia in late June 1943, Tondi approached it with professional curiosity tempered by realistic assessment of Italy's deteriorating strategic position. The captured P-38G was rolled into a hangar where Italian mechanics and engineers began their systematic examination. Unlike frontline units that might cannibalize damaged aircraft for spare parts, Guidonia's technical staff treated captured aircraft as intelligence assets. They documented everything, photographed components, measured dimensions, analyzed materials, and attempted to understand the design decisions that produced the observed performance characteristics. The Lightning would be subjected to the most thorough examination Italian aviation technology could provide. The examination process at Guidonia followed protocols the Regia Aeronautica had refined through 2 years of evaluating captured Allied equipment. Italian engineers approached the Lightning methodically, beginning with external inspection before progressing to internal systems analysis. What they discovered during those initial days of examination challenged fundamental assumptions about American manufacturing capabilities and design philosophy. The P-38G's construction quality immediately impressed the Italian technical staff. Riveting was uniform and precise throughout the airframe, demonstrating manufacturing standards that Italian factories, increasingly disrupted by Allied bombing and material shortages, could no longer consistently achieve. The aluminum alloys used in the airframe showed superior properties compared to materials available to Italian manufacturers in 1943. Even seemingly minor details like wiring harnesses and hydraulic fittings reflected a level of manufacturing sophistication that suggested American industry had not merely scaled up production but had maintained quality standards despite massive output increases. The twin Allison V1710 engines dominated the technical examination. Each engine displaced 1,710 cubic inches and produced 1,475 horsepower at sea level, with power increasing substantially at altitude thanks to sophisticated turbo supercharger systems. Italian engineers recognized immediately that these engines represented a different design philosophy from the inline engines powering Italian fighters. The Allison was built for reliability and maintainability rather than maximum power extraction. Components were accessible, tolerances were generous enough to accommodate field maintenance, and the engine was designed to continue running even when damaged. The turbo supercharger installation fascinated Italian engineers who had struggled to develop effective high-altitude performance in their own designs. Unlike mechanically driven superchargers that stole engine power to compress intake air, the General Electric turbo superchargers on the Lightning used exhaust gas energy that would otherwise be wasted. Hot exhaust gases spun a turbine connected to a compressor that forced air into the engine at high altitude, where atmospheric pressure dropped dramatically. This system allowed the Allison engines to maintain sea-level power output well above 20,000 feet, altitudes where Italian engines lost substantial power. The complexity of the turbo supercharger system revealed both American engineering sophistication and their willingness to accept complexity in exchange for performance. Extensive ducting ran through the tail booms, carrying superheated exhaust gases backward to the turbines and compressed air forward to the engine intake. This system required careful management by the pilot, with multiple controls and gauges monitoring pressures and temperatures. Italian fighters had simpler systems that were easier to maintain but could not match the Lightning's high-altitude performance. American designers had chosen capability over simplicity. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The armament installation demonstrated another distinctly American design approach. All weapons were concentrated in the nose, clustered tightly around the aircraft centerline. 4 50 caliber Browning M2 machine guns, each loaded with 500 rounds, flanked a single Hispano M2 20mm cannon carrying 150 explosive shells. This arrangement meant that all projectiles flew in parallel paths toward the target. There was no convergence point where wing-mounted guns would create a deadly cone of fire at one specific range, but be less effective at other distances. The Lightning's guns delivered the same concentrated pattern whether firing at 200 yards or 600 yards. Italian and German fighters typically mounted weapons in the wings, separated by the width of the fuselage. This required careful harmonization to make gun paths converge at a specific range, usually around 300 meters. Within that convergence zone, the combined firepower was devastating. Outside that zone, the guns were less effective because projectiles spread across a wider area. The Lightning eliminated this limitation entirely. American pilots could engage effectively at any range within their gun's effective envelope, a significant tactical advantage that Italian pilots had observed in combat but not fully understood until examining the actual installation. The cockpit layout revealed thoughtful attention to pilot workload and ergonomics. Instruments were logically grouped by function, with engine instruments clustered on the left side panel, flight instruments centered in front of the pilot, and weapons controls positioned for easy access. The control wheel, rather than a traditional stick, gave the pilot a stable platform for fine control inputs during long flights or precision maneuvers. Rudder pedals were widely spaced and comfortable, and the seat provided better cushioning than Italian fighters offered. These seemed like minor details, but they accumulated into an aircraft that reduced pilot fatigue on extended missions. The fuel system incorporated multiple tanks distributed throughout the airframe with a total internal capacity of 410 gallons. This was nearly double the fuel capacity of a Macchi C-202. Additional drop tanks could be mounted under the wings, extending range to over 1,400 miles. Italian fighters rarely flew missions exceeding 90 minutes due to fuel limitations. The Lightning was designed for marathon missions lasting 4, 5, or 6 hours. This fundamental difference in design requirements reflected broader strategic realities. American forces operated across vast Pacific distances and needed aircraft capable of long-range escort and patrol missions. Italian fighters were designed for shorter-range interceptions over the Mediterranean or North Africa. The tricycle landing gear arrangement represented another departure from conventional fighter design. Most fighters used tail-wheel configurations that sat nose-high on the ground, limiting forward visibility during taxiing and requiring careful technique during takeoff and landing. The Lightning's tricycle gear kept the fuselage level, providing excellent visibility in all ground operations and making the aircraft easier to fly for pilots with limited experience. This design choice sacrificed some weight and complexity for improved handling characteristics. Another example of American willingness to trade theoretical performance for practical operational advantages. After 2 weeks of ground examination, Tondi and the Guidonia technical staff felt they understood the Lightning's design well enough to begin flight testing. The aircraft had been thoroughly inspected. Minor damage from the forced landing had been repaired using improvised Italian components, and Italian armourers had removed the weapons and ammunition to comply with regulations prohibiting armed flight of captured aircraft. The engines were run extensively on the ground, checking all systems and ensuring reliable operation. Finally, on a clear morning in early July 1943, Tondi climbed into the Lightning's cockpit for his first flight in the American fighter. The cockpit felt spacious compared to Italian fighters Tondi had flown throughout his career. He could move his arms freely without bumping elbows against the canopy frame, and the seat positioned him high enough to see over the nose during ground operations. The control wheel felt natural in his hands, and the rudder pedals were positioned comfortably. Visibility through the teardrop canopy was exceptional, far superior to the heavily framed canopies of Messerschmitt or Macchi fighters. Tondi could see directly to his sides, above, and with only minimal restriction to the rear. In combat, this visibility advantage would allow earlier detection of threats. The startup sequence was more complex than Italian fighters required. Tondi followed the checklist carefully, activating electrical systems, setting fuel selectors, adjusting mixture controls, and monitoring multiple temperature and pressure gauges. The engines started smoothly, settling into a deep rumble distinctly different from the high-pitched scream of inline engines. The vibration through the airframe was minimal thanks to careful engine balancing and the isolation of the engines in their separate nacelles. Tondi advanced the throttles slightly, and the Lightning began moving forward with surprising ease despite its substantial weight. Taxiing revealed the tricycle landing gear's advantages immediately. The aircraft tracked straight without the weather-vaning tendency of tail draggers, and forward visibility was unrestricted. Tondi could see the entire runway ahead, judge distances accurately, and maneuver precisely without needing to swing the nose back and forth to see around the engine. He lined up on Guidonia's main runway, completed his pre-takeoff checks, and advanced both throttles smoothly forward. The acceleration was steady but not explosive. The Lightning gathered speed progressively, its substantial weight requiring more runway than lighter Italian fighters. The engines built power smoothly, with none of the torque-induced swing that made some single-engine fighters challenging during takeoff. Around 100 miles per hour, Tondi eased back on the control wheel and the Lightning lifted off cleanly, climbing away from Guidonia with stable, predictable handling. There was none of the nervous twitchiness that characterized high-performance fighters. The Lightning just flew, solid and reassuring. Tondi climbed to 10,000 feet and began exploring the aircraft's handling characteristics. The controls were heavier than Italian fighters, requiring definite input rather than feather-light touch. The ailerons especially demanded physical effort at higher speeds, and the elevator felt like moving through thick fluid compared to the instant response of a Macchi. But there was precision in that heaviness. When Tondi commanded a turn, the Lightning responded exactly as much as intended, and then stopped with no overshoot or oscillation. The stability would be invaluable for accurate gunnery, keeping the Pipper steady on target during high-speed attacks. At 15,000 feet, Tondi pushed the throttles forward and pointed the nose down. This was where the Lightning's reputation had been built, in high-speed dives that left pursuing fighters behind. The airspeed indicator climbed rapidly. 350. 400. The Lightning remained rock-solid with no buffeting, no tendency to tuck into a steeper dive, no control surface flutter. At 450 miles per hour, speeds that would cause serious concern in most Italian fighters, the P-38 still felt completely controllable and safe. Tondi pulled back on the control wheel to recover from the dive, and the Lightning converted its tremendous speed into a soaring climb that carried him back up several thousand feet in seconds. This was the Lightning's signature tactical advantage. Dive on the target with overwhelming speed advantage, fire a quick burst from the concentrated nose guns, then use that speed to zoom climb back to altitude before any defender could react. A pursuing fighter could either break off the chase or risk exceeding its own structural limits trying to follow. And if an enemy pilot did somehow manage to stay with a diving Lightning, the American could simply push the throttles forward and accelerate away using superior speed. The turning performance told a more nuanced story. Tondi rolled into progressively tighter turns at various airspeeds and altitudes, feeling how the Lightning responded. At medium altitudes and speeds, the aircraft turned, adequately but not exceptionally. Italian fighters like the Macchi C-202 could definitely outturn the Lightning in sustained turning engagements, getting inside the turning circle and achieving firing position. But Tondi realized immediately that American pilots flying Lightnings would never allow that situation to develop. Why engage in turning fights when you possessed overwhelming advantages in speed, climb rate, and altitude performance? Lightning pilots could dictate engagement terms, fighting only when conditions favored them and disengaging at will when threatened. At altitude, everything changed dramatically. Tondi climbed to 25,000 feet and discovered that the Lightning's performance actually improved as the air thinned. The turbo superchargers compensated for decreasing atmospheric pressure, maintaining engine power where Italian engines would gasp for oxygen. The Lightning climbed strongly past 30,000 feet, altitudes where Italian fighters became sluggish and unresponsive. At these heights, the P-38 retained speed, maneuverability, and full control authority, while Italian interceptors struggled just to maintain formation. This high-altitude dominance explained why Allied bomber formations could operate with relative impunity at altitudes Italian fighters could barely reach. Tondi spent over an hour exploring the Lightning's flight envelope, testing stalls, evaluating control response at different configurations, and simulating combat maneuvers. When he finally turned back toward Guidonia and began his approach, he had formed conclusions that would challenge Italian tactical doctrine. The Lightning was not invincible. It had weaknesses that could be exploited by skilled pilots using appropriate tactics. But it possessed fundamental advantages in the characteristics that mattered most for the kind of aerial warfare being conducted over the Mediterranean in 1943. Speed, altitude performance, range, firepower, and pilot visibility all favored the American design. The landing approach revealed another thoughtful design feature. The Lightning's low-speed handling remained docile and forgiving. There was no tendency toward wing drop or snap roll, no vicious stall characteristics, nothing that would surprise or trap an inexperienced pilot. Tondi brought the aircraft across the runway threshold at 120 miles per hour, reduced power smoothly, and touched down gently on the tricycle landing gear. The nose wheel tracked straight during the landing rollout, without the ground-looping tendency that made tail draggers challenging for novice pilots. Everything about the Lightning's design seemed intended to make the aircraft accessible to pilots of average skill, rather than demanding exceptional ability. Tondi's initial evaluation report to Regia Aeronautica headquarters was comprehensive and sobering. The Lightning represented a mature, well-integrated design that achieved its intended mission objectives through careful engineering rather than exceptional performance in any single category. It was fast, but not the fastest. It was maneuverable, but not the most agile. It climbed well, but not better than specialized interceptors. What made the Lightning dangerous was the combination of capabilities that allowed American pilots to fight on their terms, engaging when advantageous and disengaging when threatened. Italian pilots in conventional fighters had no effective counter to this tactical flexibility. The report detailed specific recommendations for Italian fighter tactics when engaging Lightnings. Attack only with substantial altitude advantage. Use diving attacks and disengage immediately. Never attempt sustained turning fights at altitude. Always maintain awareness of escape routes. Force combat at low altitudes where Italian fighters retained some maneuvering advantage. These recommendations acknowledged reality. Italian fighters could not match the Lightning's overall capabilities, so Italian pilots would need to exploit the narrow circumstances where they retained advantages while avoiding situations that played to American strengths. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But Tondi's evaluation flights at Guidonia were just the beginning of the Lightning's second life in Italian service. In August 1943, as Allied forces advanced through Sicily and prepared for the invasion of mainland Italy, the captured P-38G remained operational at Guidonia. On August 11th, Tondi received alert of an American bomber formation approaching Rome, returning from a raid on targets in central Italy. The formation consisted of approximately 50 B-17 flying fortresses, their tight defensive boxes bristling with 50 caliber machine guns. Italian fighters scrambled to intercept, and Tondi made a decision that would become one of the more unusual episodes of the Mediterranean Air War. He took off in the captured Lightning to join the intercept. Flying a captured enemy aircraft in combat was not unprecedented. Both sides had occasionally used captured planes for specific missions, usually to create confusion or to test whether recognition failures might provide tactical advantage. But Tondi's sortie on August 11th was not a deliberate deception operation. It was an opportunistic decision by an experienced pilot who happened to have a superior aircraft available and wanted to test his evaluation conclusions under actual combat conditions. The Lightning bore Italian markings, hastily painted to identify it as friendly, but in the chaos of aerial combat, recognition was often difficult, even when aircraft wore correct colors. Tondi climbed rapidly to intercept altitude, the Lightning's powerful engines pushing him through 25,000 feet with ease, while Italian fighters labored to reach the same altitude. He positioned himself above and ahead of the bomber formation, using the Lightning's speed advantage to select the most favorable attack geometry. Then he rolled into a diving attack on the lead element of the formation, the Lightning accelerating rapidly as it plunged toward the bombers. The concentrated nose armament would have allowed precise fire, but Tondi was flying an unarmed evaluation aircraft. Nevertheless, he pressed the attack to evaluate how the Lightning performed in combat conditions. The B-17 crews reacted with disciplined defensive fire, multiple gunners tracking the approaching fighter and filling the air with tracer rounds. Tondi broke off his simulated attack and pulled up sharply, the Lightning's exceptional dive speed carrying him safely away from the bomber formation before defensive fire could track him effectively. Then he reversed and made a second pass, this time from a different angle, evaluating how the Lightning's speed and climb capability allowed hit-and-run tactics that minimized exposure to defensive fire. The bomber crews must have been confused by what appeared to be a P-38, making aggressive passes but not firing. Historical records become murky regarding exactly what happened next. Some accounts claim that Tondi, flying the armed Lightning days later or on a subsequent mission, actually engaged American bombers and scored hits on multiple aircraft. Italian records credit Tondi with damaging a B-17 designated Bonnie Sue, serial number 42-3307, which crashed into the Mediterranean near Torvajanica, with several crew members parachuting to safety. Another report from the 301st Bomb Group mentions losing B-17, the Lady Evelyn, on September 4th to an enemy P-38, which would have been Tondi's captured aircraft. These claims are difficult to verify conclusively. American loss records sometimes attributed aircraft losses to causes that were uncertain or misidentified in the confusion of combat. Italian combat claims, like those of all air forces during the war, sometimes reflected optimistic assessments rather than confirmed kills. What is certain is that Tondi flew the captured Lightning on multiple occasions during August and September 1943, that he used it for both evaluation purposes and opportunistic combat missions, and that his experiences provided Italian tactical planners with valuable insights into American aircraft capabilities. The operational life of the captured Lightning ended in September 1943 when Italy signed the armistice with Allied forces. The rapid German occupation of much of central and northern Italy threw the Regia Aeronautica into chaos. Some units continued fighting alongside German forces, others surrendered to the Allies, and many simply disintegrated as pilots and ground crews fled or returned home. The fate of the specific P-38G captured at Capoterra remains unclear. It may have been destroyed by retreating Italian forces to prevent capture by advancing Germans. It may have been seized by German units and transported north for evaluation at Luftwaffe facilities. It may have been recaptured by Allied forces and returned to American service. Records from this chaotic period are incomplete and contradictory. What survived was the intelligence gathered during the aircraft's brief service with Italian forces. Tondi's detailed evaluation reports, the technical analyses compiled by Guidonia engineers, and the tactical recommendations developed from actual flight experience all contributed to a more realistic understanding of what Italian and German pilots faced when engaging American fighters. The Lightning was not invincible, but it was exceptionally well suited for the strategic mission American forces needed to accomplish. Long-range escort of bomber formations deep into enemy territory. Part 3. The cost of truth. The broader significance of the captured Lightning extended beyond tactical might, intelligence. For Italian pilots and engineers who examined the aircraft, it provided undeniable evidence of American industrial and technological capabilities that propaganda had consistently understated. The comfortable assumption that American aircraft were crude but numerous, simple but adequate, could not survive direct experience with the Lightning's sophisticated engineering and quality construction. This was not a machine produced by an industrially unsophisticated nation throwing together vast quantities of acceptable equipment. This was the product of advanced engineering, refined manufacturing processes, and thoughtful attention to operational requirements. Italian engineers recognized specific design features that reflected American advantages in industrial capacity and strategic resources. The extensive use of high-quality aluminum alloys throughout the airframe required access to raw materials that Italy could no longer obtain reliably. The sophisticated turbo-supercharger system depended on precision manufacturing capabilities and quality control standards that Italian factories, disrupted by bombing and material shortages, struggled to maintain. Even seemingly minor details like electrical wiring, hydraulic fittings, and instrument quality revealed the depth of American industrial superiority. The Lightning's design philosophy also challenged assumptions about what made effective fighters. European tradition emphasized lightweight construction, minimal drag, and exceptional maneuverability for close-quarters dogfighting. The Lightning sacrificed some of these characteristics for others that proved more valuable in actual combat: speed, range, altitude performance, firepower, and pilot survivability. American designers had apparently concluded that the era of turning dogfights was ending, replaced by high-speed hit-and-run tactics where positioning, energy management, and situational awareness mattered more than instantaneous turn rate. This represented a fundamental disagreement about the nature of aerial warfare. Italian and German designers continued refining aircraft for traditional dogfighting throughout the war, producing machines like the Machi C-205 and Focke-Wulf Ta-152 that excelled at close-range maneuvering combat. American designers moved toward aircraft that avoided that kind of fighting entirely, using speed and altitude advantages to dictate engagement terms. The strategic results suggested that the American approach better matched the realities of industrial-age warfare, where numerical superiority and technological advantages mattered more than individual pilot skill in traditional dogfighting. The psychological impact on Italian pilots who flew against Lightnings, informed by reports from Tondi and other test pilots, contributed to declining morale in the final year of Italy's participation in the war. Pilots understood they were flying inferior aircraft against opponents with overwhelming material advantages. This knowledge did not eliminate their courage or professionalism, but it created a sense of futility that corroded unit effectiveness. Why press attacks against superior American fighters when the strategic situation was clearly hopeless? Why risk death in obsolescent aircraft when the war was already lost? German forces that continued fighting in Italy after the September 1943 armistice learned similar lessons from their own encounters with Lightnings. Luftwaffe intelligence incorporated Italian evaluation data into their assessments of American aircraft capabilities. German tactical doctrine evolved to emphasize avoiding combat with American fighters whenever possible, focusing instead on attacking bombers before escorts arrived or after they departed. But the Lightning's exceptional range made this tactic increasingly ineffective. American escorts could now accompany bombers throughout entire missions deep into German-controlled territory. The Lightning's success in the Mediterranean and Pacific theaters validated design decisions that seemed questionable when the aircraft first entered service. Early models suffered from various problems, including compressibility issues in high-speed dives, inadequate cockpit heating at altitude, and engine reliability concerns. Lockheed engineers systematically addressed these issues through ongoing development, producing progressively improved variants that refined the basic design without fundamentally changing it. The P-38J and P-38 liters models, introduced in 1944, incorporated power-assisted ailerons, dive recovery flaps, improved intercoolers, and uprated engines that boosted maximum speed to 420 miles per hour. The concentrated nose armament that impressed Italian evaluators proved devastatingly effective in combat across all theaters. Unlike fighters with wing-mounted guns that required careful convergence settings, Lightning pilots could engage effectively at any range. The four 50-caliber machine guns and single 20mm cannon fired in tight parallel, creating a stream of projectiles that required only accurate aim rather than precise range estimation. This advantage was especially valuable against lightly armored Japanese aircraft in the Pacific, where Lightning pilots achieved exceptional kill ratios. The top two American fighter aces of World War II both flew Lightnings exclusively. Major Richard Bong achieved 40 confirmed victories flying P-38 seconds in the Pacific Theater, while Major Thomas Maguire scored 38 kills, also in a Lightning. These individual achievements reflected broader patterns of Lightning effectiveness. In the Pacific, P-38 seconds were credited with destroying more Japanese aircraft than any other American fighter type, a remarkable record for an aircraft that faced criticism in the European theater for alleged shortcomings against German fighters. The Lightning's range capability enabled missions that would have been impossible with shorter-range fighters. The most famous Lightning mission occurred on April 18, 1943, when 16 P-38Gs flew from Guadalcanal to intercept Admiral Isoroku Yamamoto, architect of the Pearl Harbor attack, who was flying to inspect Japanese troops on Bougainville. The round-trip distance exceeded 1,000 miles over open ocean, requiring precise navigation, perfect timing, and aircraft capable of sustaining that range. Only the Lightning could accomplish the mission. The interception succeeded, both Japanese transport aircraft were shot down, and Yamamoto was killed. The Lightning had eliminated one of Japan's most capable military leaders through a mission dependent entirely on the aircraft's exceptional range. Reconnaissance variants of the Lightning, designated F-4 and F-5, proved equally valuable. The removal of armament and installation of cameras created aircraft capable of penetrating deep into enemy territory at high altitude and speed, gathering intelligence that conventional reconnaissance aircraft could not obtain. In Europe, F-5 Lightnings obtained approximately 90% of the aerial photography used for bomb damage assessment and target planning. The same speed, altitude performance, and range that made the Lightning effective as a fighter made it exceptional as a reconnaissance platform. The Lightning remained in production through 1945, with approximately 10,000 aircraft built across all variants. Production ended shortly after the Japanese surrender, and the Lightning was rapidly retired from American service as jet aircraft entered operational units. But the Lightning's influence extended beyond its wartime service. The design philosophy it embodied, emphasizing speed, range, and firepower over traditional dogfighting agility, became dominant in post-war fighter development. Modern multi-role fighters prioritize precisely the characteristics the Lightning pioneered: high speed, long range, sophisticated systems, and concentrated firepower. The captured Lightning that Lieutenant Colonel Tondi flew from Guidonia Airfield represented a brief moment when Italian pilots and engineers could examine firsthand what they faced in combat. The conclusions drawn from that examination were professionally honest and tactically sound, but they could not change strategic realities. Italy lacked the industrial capacity, raw materials, and technological sophistication to produce equivalent aircraft. Italian pilots would continue flying obsolescent fighters against superior opponents until the armistice removed Italy from the war entirely. The Lightning's story illustrates how industrial capacity and technological sophistication ultimately determined aerial warfare outcomes during World War II. Individual pilot skill mattered, tactical innovation was valuable, and courage remained essential. But nations with superior industrial capacity producing sophisticated aircraft in overwhelming numbers possessed decisive advantages that skill and courage alone could not overcome. The Lightning epitomized American industrial power, technological capability, and willingness to invest resources in aircraft that prioritized pilot survivability and mission effectiveness over theoretical performance maxima. For the American pilot who inadvertently landed his Lightning on enemy soil in June 1943, the navigation error ended his war prematurely and cost him months in a prisoner of war camp. For the Regia Aeronautica, that same error provided invaluable intelligence about the aircraft terrorizing Italian forces across the Mediterranean. For aviation history, the captured Lightning and its brief evaluation by one of Italy's most experienced test pilots offers insight into how professional military organizations attempted to understand and counter superior enemy capabilities, even when strategic defeat was inevitable. The Lightning that Tondi flew from Guidonia demonstrated that American aviation engineering had achieved sophistication and quality that exceeded Axis assumptions. The aircraft combined advanced technology, thoughtful design, and excellent construction into a weapon system optimized for the strategic missions American forces needed to accomplish. Italian pilots and engineers who examined the Lightning could appreciate its engineering excellence and tactical effectiveness while regretting that their own industry could not produce equivalent capability. That honest professional assessment, documented in Tondi's evaluation reports and preserved in Italian military archives, stands as testimony to the reality that industrial-age warfare ultimately favored nations with superior resources, technology, and manufacturing capacity. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.